Hey YouTube, how's it going? YakScience here with another o-chem video. The topic today is going to be alkene reactions. I'm going to be going over virtually all of the alkene reactions that you'll most likely be responsible for in your o-chem course. This is meant to be sort of a pre-test, last-minute review of all of the alkene reactions. We're not going to go into the mechanism, we're just going to do reactant, reagents, product, and then a couple characteristics of that reaction, like is it regiospecific and is it stereospecific? So let's dive in. Alright, so first we have hydration reactions. We have three different types that you're typically responsible for. Acid-catalyzed hydration, hydration via oxymercuration, demercuration, and hydration via hydroboration oxidation. So let's talk about this one first. The product for this reaction, acid-catalyzed hydration, looks like this. Alright, and notice that the OH group that's added is on the more substituted carbon, so we could say this is regiospecific, and specifically, it follows Markovnikov's rule. So we could write regio, yes, and is it stereospecific? The answer is no. So let's write stereo, and let's draw an X. It's not stereospecific because remember the mechanism involves the formation of a carbocation, and it yields a racemic mixture, so this is not stereospecific. Alright, and for the second type of hydration, oxymercuration, demercuration, the product is going to look like this. Alright, so this is the product. Notice that the OH once again is on the more substituted carbon, so this is regiospecific, and it follows Markovnikov's rule, just like this one. And also notice that the OH and the H are anti to one another, so this is stereospecific. Let's draw stereo and then a check mark. And it is anti-addition, right? The OH and the H will be anti to one another, pointing in opposite directions. And finally, hydroboration oxidation, the product is going to look like this. Alright, so this is the product. Notice first of all that the OH is on the less substituted carbon. So this is regiospecific, but unlike these two, it is anti-Markovnikov, okay? So regio, we're going to say it is, but it's anti-Markovnikov. In terms of stereospecificity, notice that the OH and the H are syn to one another. So stereospecific, yes it is. So let's draw a check next to stereo. And know that it is syn addition. Okay, so just to review, syn addition, anti-addition, no stereospecificity, anti-Markovnikov, Markovnikov, Markovnikov. Okay, let's move on to the next category. Alright, so next let's talk about hydrohalogenation. Notice we have an alkene and HBr. This can also be done with HCl and other H somethings, H halogens, except for HF, okay? Won't work for HF. So the product for this looks like this. Alright, this is what the product looks like. Notice that the Br is on the more substituted carbon, so this is regiospecific, and it follows Markovnikov's rule. Okay. Is it stereospecific? The answer is no, because if you look at the mechanism for this, which I made a video on it, I highly recommend it, it involves forming a carbocation. So just like acid-catalyzed hydration in the previous example, the formation of carbocation means that there is no stereospecificity. So for stereo, we're going to draw an X. Okay. Let's move on to the next type. Alright, the next type of reaction is halogenation. It involves Br2 and CCl4. You can also do this with I2 or Cl2. And the product looks like this. Notice that you have two Brs, two halogens across the pi bond, and they are anti to one another. So first let's talk about, is this regiospecific? The answer is no, because we added two of the same carbon across the pi bond. So technically, check with your teacher, but technically we consider this not regiospecific. Okay. And in terms of stereospecificity, notice that these are anti to one another, and that has to do with the mechanism. It involves a nucleophilic attack similar to an SN2 reaction at some point. But watch the video on this if you want to learn more about that. But long story short, stereospecificity, yes, right? It is anti-addition, okay? They will always be pointing in opposite directions. Let's keep going. All right, the next type of reaction is hydrogenation, okay? This involves taking an alkene, reacting with H2 and platinum as a catalyst, and the product looks like this. All right, notice that you end up with two hydrogens across this pi bond. So in terms of regiospecificity, we're going to say it's not regiospecific because you're adding two of the same atom across the pi bond. So let's put an X next to regiospecific. In terms of stereospecificity, notice that they added on the same side or syn to one another. So it is stereospecific. And it involves syn addition, okay? Let's move on. Alright, the next type of reaction is dihydroxylation of alkenes. You take an alkene, you react it in a two-step mechanism. First, osmium tetroxide, or OSO4, and THF. And in the second step, H2S, okay? And the product is going to look like this. Alright, so notice that we added two OH groups across the pi bond. That's why it's called dihydroxylation. So in terms of regiospecificity, we could say it's not regiospecific. so not regiospecific. Check with your teacher because sometimes with certain reactions where I'm saying that, you know, two of a kind are added, sometimes the mechanism is regiospecific, but the product isn't. So you always want to double check with your teacher with what I'm telling you about regiospecificity, because it could differ. For example, with halogenation, the Br2 mechanism, or Cl2 or I2, upon attack, right, there is an attack on the more substituted carbon if you watch the video. But nonetheless, the fact that you end up with two of the same kind in halogenation warrants the fact that it's not regiospecific. But check with your teacher, just want to put that out there. But for now, it's not regiospecific. In terms of stereospecificity, notice that the two OH groups are syn to one another, so yes, it is stereospecific. And it involves syn addition, right? And you end up with a vicinal diol, okay? Let's keep going. All right, the next type of reaction is called oxidative cleavage, also known as ozonolysis. And the reason it's called ozonolysis is because we're using ozone, right? Let's talk about the reagents first. First step of this mechanism, ozone, O3, and CH2Cl2, and then the second step, CH3,2S. So the product looks like this. All right, so this is what the products would look like. Notice we end up with two products because it's cleavage, right? We're cleaving this pi bond, this double bond, and forming two molecules. Well, they'll always be carbonyls, but you have to be careful in terms of whether it forms a ketone, an aldehyde, etc. So in this case, we formed a ketone and an aldehyde because notice this carbon was bonded to two R groups, so two carbons, right? Two other R groups, so that became a ketone. But this carbon was only bonded to one other carbon and a hydrogen. That's why this became an aldehyde, right? So always check for that. But in this case, these would be the two products. Okay. And in terms of regiospecificity and stereospecificity, that doesn't really apply here because of the way the mechanism works. So just know that it's not regiospecific and it's not stereospecific, okay? Let's keep going. All right, the last reaction we're going to talk about is epoxidation via MCPBA. Remember that an epoxide is a cyclic ether with three atoms, right? Two carbons and an oxygen. So we make those by reacting an alkene with MCPBA and CH2Cl2. So the product of that reaction looks like this. All right, so this is what the product looks like. We end up with an epoxide. And notice that both of these lines are dashed, which suggests that in terms of stereospecificity, this is syn addition, right? Because, you know, yes, these two are bonded to the same atom, the oxygen, but they are both dashed, and so we could say that they are syn to one another. So let's just write stereospecificity. Yes, sorry, let's put a check mark there. Stereo, yes. In terms of regiospecificity, notice there is no regiospecificity because essentially these two are sharing this atom, so obviously the atom isn't like on one carbon versus another carbon, so it is not regiospecific. And one last note about this, you do get a side product. Alright, so the side product looks like this. I hope you could see it. It's a benzene and then a carboxylic acid. So this just occurs because of the mechanism. I made a video about the mechanism. I highly recommend it. So that's it for alkene reactions, and I really hope this was helpful. Thanks so much.